you know, let's say you have something that maybe previously was 10 or 15 parts, and then you had to join them all together. You actually can use a 3D printer and 3D print all those parts conjoined. Because when you can 3D print joints, which means I can 3D print something that moves, that's interlocking. There's a, Sunday I was at the Comic-Con. There was a Comic-Con in Kathmandu. There's a 3D printer at the Comic-Con, and the 3D printer had what was called a infinity gear, and it shows how that one 3D printer printed interlocking parts. So it's actually another big reason why people use 3D printing, because it cuts down the assembly. And there's another way to think about, you know, designing for 3D printing, where can I cut down the assembly? Because I can 3D print interlocking parts. It's a great question. Yes.
Usually you talked about printing 3D prints. I'm sorry. You should talk about 3D printing the stuff you use in satellites, right?
Yes.
But instead of launching those, instead of printing only small things inside satellite, can't we just 3D print the whole satellite from outer space so that we don't have to launch it from Earth or something?
Yeah. So, great question, right? And that's part of what NASA is starting to think about. It's called interstellar extraterrestrial 3D printing. And so it's around how do we 3D, so NASA and American Makes, which is my company, just recently had something called the 3D Printed Habitat Challenge, where they challenge people to think about if we wanted to 3D print structures on Mars, how would we use the material from Mars to 3D print a house on Mars? That's one. The other thing they're starting to think about is how do we mine asteroids? Asteroids have lots of precious metal. They have titanium, they have iron, they have platinum. So they're actually, you know, Elon Musk, you guys know Elon Musk? Yeah. These crazy individuals, they're the ones sending out, trying to figure out how to mine asteroids. Because they recognize exactly like that we can start going into space, mining from either Mars or asteroids, mining metals, taking that feedstock back to either the International Space Station or to a manufacturing facility on Mars, let's say, and using it to start 3D printing stuff like satellites or homes or whatever. Yeah.
Yeah. What is the cost of the 3D printing printers?
Yeah.
In relation to the materials they use? Like if you want to print ornament,
Yeah.
they use that in the powder format?
The most expensive material, well, there's two. There's the printer and the material. The most expensive printers right now are the metal 3D printers. They're most expensive ones. The cheapest ones are the ones that are going to print in ABS and PLA plastic. Those are the cheapest. It's also the cheapest material. The most expensive ones right now are I would say the metal 3D printers. The metal filament, the powder, is also expensive, but I will say one of the costs is around, you know, like the HP model, like, you know, the cartridge, the printer's cheap, but the cartridge is expensive, like they have a razor blade model. A lot of 3D printed companies use the razor blade model, so sometimes the feedstock will be more expensive than it would normally be, because that's their business model. But metal, I would say, is the most expensive. That would actually be a great chart to have, like, to say how the costs. I don't have that, but it's anywhere between, you know.
And any disruptive thing happens in this speed of the printers?
Disruptive?
Yeah, in classes.
Oh yeah, I mean Carbon 3D I just mentioned completely disrupted the industry. Last year they kickstarted their project. Kickstarter, you guys know Kickstarter?
Yes.
Kickstarter has transformed the 3D printing industry. It has transformed the 3D printing industry because the combination of expired patents, cheaper technology, and access to capital through Kickstarter allowed people to make things that they could never have made before. It was why the MakerBot started, and it's why Carbon 3D just recently disrupted the industry. Like I said, that's the one that they print. Literally, it takes 5 minutes to print something that would have taken about 5 to 10 hours previously. Because they use that photopolymerization. That they have a new method where they basically shoot thousands and thousands and thousands of layers into the liquid, so it just kind of merges. 5 minutes. And I will say, when that They had a YouTube video a year and a half ago. I was working at a 3D printing company. We all watched the video. Do you guys know the term Pollyanna? It's like someone who's like very optimistic. I'm a little optimistic. I have a colleague of mine, very so anyway, we watched the video. I was like, this is amazing. My colleague's like, that's never gonna happen. That's called magic. And I was like, no, I think it is. 2 weeks ago, I was at Carbon. I watched it. They figured it out, 5 minutes.
And how was the misapplication cost? Including painting and
Yeah, so this object, this would probably cost, if you know, if, let's say the file was free because somebody else designed it or you designed it, you have access to the printer, and all you had to do is pay for the material, I'd say maybe $10 to $12. Yeah, $10 to $12. The other thing is depending on how much, so when you look at the file, you'll know if this is a solid or hollow. If it's hollow, it will be cheaper. If it's solid, it will be more. If it's hollow, it will be less strong. If it's solid, it will be more strong. If you collect trash, turn your trash into 3D printed filament and make your own filament. I've never done it. I have friends who do it. I think it depends on the word difficult. I mean, I think you could figure it out. I don't think it's as easy as, you know, making a cake, but I think you could figure it out. Any other questions?
I have one question. So since it's possible to just hack up the 3D printer to print out foods, then is it possible to figure out the chemical composition of some compounds and then print those compounds just like diamonds or something?
You know, somebody asked me that, could you 3D print diamonds? I know diamonds are, you need extreme heat to print a diamond, so I don't know about a diamond. But that's exactly, the question that you're asking is exactly what the bioprinting question is asking. They're basically saying, can we figure out the chemical compounds? And you're asking if it's possible. My personal opinion is if you can imagine it, it's possible on some level. So I definitely think that's something, you know, that people are exploring specifically around bio-3D printing. Thinking about how can we, you know, there was a story about hydrogen particles that I'm not remembering. But somebody was doing something specifically with hydrogen and combining molecules within the 3D printer. So that's R&D right there. That's some definite R&D that's happening. Yes.
As anyone could make anything, doesn't it seem like a trade from criminal mind?
I'm sorry? Is it a trick? For a criminal mind? So my old CDO used to talk about what he called unintended consequences, and that all technologies have unintended consequences. You know, computers have huge unintended consequences with, you know, with criminal hacking and things like that. So the answer is yes. You know, about 5 years ago, there was a big issue around 3D printed guns. A guy named Corey, I think his name is Cody. Cody, he basically created an entire file for a gun, so you could 3D print it, so that you know, you could shoot it. I would never shoot this gun because it will probably actually explode in your face, and you know, so probably not a good idea. But that being said, yes, absolutely, there are unintended consequences that happen. And in the U.S., the 3D printing industry takes that seriously. I know 3D Systems had, you know, kind of a advisory group to think about unintended consequences. A big one is IP. So, if you can imagine, if the Air Force is using a 3D printer to replace parts on airplanes, or let's say even on missiles, right? Let's just say. And they have a file, and you can 3D print that file. And that file lives on what's called the digital thread in the cloud. But I have a criminal mind, and I want to mess with your Air Force. And I hack your file, and I disrupt the strength and structure of your component part, so that it's no longer a strong structure, even though you think it is. And when you print it out and you put it on your plane, it blows up. That's a very real concern, cybersecurity and cybersecurity around 3D printing. So certainly, I think any kind of technology is exposed to criminal minds, and you're smart enough, you can figure out how to do something for evil as much as for good. So yeah.
Why it has been named as 3D printing? It is giving out to three-dimensional.
Yeah. Yeah.
It has been named as manufacturing.
Yeah, so 3D printing in the 1980s, 3D printing was invented in 1986. And it wasn't called 3D printing. It first was called rapid prototyping. Then it was called additive manufacturing. So traditionally 3D printing is called rapid prototyping and additive manufacturing. In 2007, when the Kickstarter campaign happened and 3D printing kind of became commercial, Avi Reichenthal, who's the previous CEO of 3D Systems, actually named it 3D printing, three-dimensional printing. And he did it because he thought it would be mass media, like he thought the average everyday person would resonate with the name. So it got coined 3D printing, three-dimensional printing, because it means the print heads, the FDM print heads are very similar to the inkjet printer nozzles. The ones that do binder jetting are very similar to like the Xerox nozzles. So I think that they thought, okay, well, we could call it 3D printing. But it does confuse people, and it's a definite conversation for debate. There's advanced manufacturing, additive manufacturing, rapid prototyping, and 3D printing. Essentially are all the same thing, except advanced manufacturing is a higher bucket for all the other ones. Anybody else? Thank you for all your questions. They're great.
Thank you, Rian. It was indeed an interesting section. I had goosebumps on myself. Like, is it real? Like, is it printing everything that we just need to imagine, and then the products that we have imagined is in our hands. It's actually is a disruptive technology. So